So now we're going to talk about graphing other basic functions. And so we're going to look at their graphs. And actually the first two are just special cases of linear equations. First one is the constant function, f of x equals b. Again, think of y equals b. That's just a horizontal line going through the y value of b. We have the identity function, y equals x. And that's just a straight line, a line with slope of 1 that goes through the origin, 0, 0. And then so for both of these, we've talked about this before, that the domain here is going to be all real numbers for this constant function, but my range is going to be value of b. And here we got an equation where the slope, a linear equation where the slope is not 0 and not undefined, so my domain and range is going to be all real numbers. Now, next function we're going to talk about is the absolute value function. And remember, the absolute value function, what it does, any value I plug in for x, it's going to make the value positive. So if I were to do a quick little table here, if I take the absolute value of -2, that's positive 2. The absolute value of -1 is positive 1. Absolute value of 0 is 0. Absolute value of 1 is positive 1. And absolute value of 2 is 2. And if you plot those points, you get this characteristic V shape. So always think of the absolute value as being like a V shape. Now in terms of my domain, again, if I flatten this out, squish it down here, my domain here would be all real numbers. My range, however, when I squish it this way, well, my y values don't start until y equals 0. So it's going to be from 0, including 0, to positive infinity for my range. The next one is the square function. Its graph is what we call a parabola. And so whatever your x value is, you're squaring it to get your y value. So if I square -2, that's a positive 4. If I square a -1, it's 1. Square 0 is 0. Square 1 is 1. Square 2, that's 4. And you get this characteristic U shape. This is called a parabola. And we'll actually be studying parabolas a lot more in this section. And you notice I've been marking some points here on this graph. So you want to know what these basic functions are, and also know that these points here are on the graph, because that's going to help us later in this section. My domain, again, if I go through and flatten this out, it's going to land on the x-axis, so my domain is going to be all real numbers. And if I flatten this out on my y-axis, my range is going to start at 0 and go to positive infinity. So my domain is from -infinity to infinity. My range is from 0 to infinity, including 0. All right, let's turn the page. And the next function we're going to look at is a cube function. So now we're cubing our values. So again, if I were to do my little table here, now if I cube a -2, that gives me a -8. If I cube a -1, that gives me -1. If I cube a 0, 0. If I cube 1, that's 1. And if I cube 2, that gives me 8. So you can see that -2, -8 is somewhere down here, and that positive 2, 8 is somewhere up here. They're off the graph. And you get this kind of twisting little graph here for our cube function. And again, I'm just kind of marking some points. You want to know that these points are on this graph, and you want to know what the shape looks like for the cube function. In terms of my domain and range, if I squish this down for my range, it's going to land on the y-axis. So my range is going to be all real numbers. And if I squish this down this way, the graph will eventually land on the x-axis, so my domain is also going to be all real numbers. So the domain and range for both of them is all real numbers. The next one is the square root function. Square roots are only defined when x is greater than or equal to 0. So if I were to pick 0, 1, and 4, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And it kind of looks like our square function that's been turned on the side and cut in half. And so again, these are some common points here. Now in terms of my domain and range, when I squish this down, so I go ahead and I flatten this out, where it lands on the x-axis starts at 0, goes to positive infinity. Likewise, the same thing when I flatten this out here, it's going to land on my y-axis, starting at 0, going to positive infinity. So my domain and range here are 0 and the positive real numbers. So that's how we write in interval notation. Again, if someone says square root, you need to have this picture in your mind with these 3 points. Because later when we shift, we're going to be using these points to help us shift. Now, not to be outdone, we can do the cube root function. If we take the cube root of -1, that's -1. Cube root of 0 is 0. Cube root of 1 is 1. If I were to do the cube root of 8, that would give me 2, so that point would be somewhere out here. Likewise, if I were to do the cube root of -8, that point would be somewhere over here. And it kind of looks like the cube function, but it's been turned on its side. If I flatten this out, it's going to get my entire x-axis, so my domain's all real numbers. Likewise, since this extends on forever, when I flatten it out this way, I'm going to get my entire y-axis. So my domain and range here are going to be all real numbers. Next one is the reciprocal function. F of x equals 1 over x. Notice this is undefined when x equals 0. So in terms of my domain and range, if I kind of plot some points here, and I'm just going to kind of look at this side for a minute. If I were to take my x value, let's take x equals 2, 1 and a half. 1 over x means I flip it over upside down, so that 2 becomes 1/2. 1 becomes 1, 1/2 becomes 2. So we get these points here. And these points here, when we draw the graph ends up hugging the x and y axis. And we can do the same thing for the negatives over here. We get this piece over here. In fact, later in the course, you can kind of notice that this graph here, as the x values get closer and closer to 0, approaches the y-axis. The y-axis, which is the equation x equals 0. This is called a vertical asymptote. And similarly, this would be y equals 0 would be a horizontal asymptote. And we'll see that later in the course. So my domain here is all real numbers except for 0. Same thing for my range. The only value I cannot get is 0. So I'm just going to note here that we have a horizontal asymptote of y equals 0 and a vertical asymptote of x equals 0. Again, that's going to become important later. So make sure you know what these graphs look like. Make sure you have them memorized with the points so that when we do our shifting, stretching, reflecting in the next part, having that basic function already memorized is going to make life a lot easier.